We live in a digital world now, and participating in the digital economy is an imperative for all. These videos are designed to help you quickly understand the key digital topics and the technologies in approximately 5 minutes. A number of 2017 industry analyst reports indicated that many organizations are not really progressing fast enough with leveraging digital technologies for business value. Mckinsey and Company indicated that less than 40% of organizations are digitized. dyanTrace, in a survey of over 1,200 organizations, found 48% of survey participants indicated digital performance challenges were hindering their success in their digital transformation. A 2017 OECD study for the G20 meeting on the key issues for digital transformation indicated that 50% of organizations experience one or more of the challenges we shall shortly present, slowing down their participation in the digital economy. A review of industry reports and studies, as you can see here, from leading analysts and digital leaders, comes up with a pretty consistent list of the top challenges that limit or slow digital transformation. We shall take a look at these now. Lack of a clear vision and strategic intent relating to leveraging digital for business value is a limiting factor in setting the direction and focus for the organization. Lack of knowledge and competence that gives leaders the confidence to set the right vision and plan, and for other stakeholders the ability to productively contribute in the transformation. Attitudes towards existing systems and technology presents a barrier to new technology adoption, whether it be sunk cost or emotional investment, or perceived technical challenges such as integration and interoperability. Performance management and return on investment visibility is an issue, where organizations are not experiencing the impact of their technology investment. Lack of focus on the customer and their digital engagement and journey in the acquisition of your organization's products and services, another important issue that slows down digital transformation. Inertia at all levels. At the highest level, the perception of risk that significant change to the business or business model might bring, right down to the operational level, where fear of the unknown and what might be the consequences of digital transformation for the individual or teams. Digital transformation can enable and require culture change. Digital has the potential to change how individuals live and work. The brain is effectively an organic computer that leverages physics, chemistry, and biology to sense, respond, and carry out its human functions. Human intelligence is reflected in how we sense, receive, process, and respond to input signals of many types. 5 of our senses you will be familiar with. 2 may be new to you. Vestibular relates to our body's perception in relation to gravity, movement, and balance. Proprioception relates to the sense of relative position of neighboring parts of the body and the strength of effort being employed in movement. Cognitive functions are the mental processes that allow us to receive, select, store, transform, and recover information we receive from external stimuli. This process allows us to understand and relate to the world around us more effectively. And the key sections that we look at in cognitive function are attention, memory, executive functions, language, visual and perception, and spatial perception. The resulting intelligence is perceived from the individual's posture and response to stimulation or inputs, which may be visible or invisible. Some examples include, from the list, self-awareness, social awareness, listening, communication, and movement. The brain is analogous to an extremely powerful computer, not yet available in terms of its power of volume, velocity, and variety of information processed and responded to. The quality of the measured response is a measure of intelligent quotient, and the human brain provides very high performance. Now let us look at machine-based intelligence. Usually envisioned as machine intelligence level equating to human intelligence level, where a machine can do one, some, or all of what a human can do. We know that there are many of these outcomes that machines can now demonstrate, but not all, and few to the level a human can do. Of course, we also know there are some things machines can do at a level humans cannot, such as precision of movement and action, or volume, velocity, and variety of data processing when it comes to a specific set of rules and functions. The basic model for a machine we use is displayed. Relative to humans, machines have limited processing power. Humans do extensive parallel processing. Relative to humans, machines have limited processing ability. Though a component of intelligent machine applications, say robotics or data processing, contribute to digitization and automation of processes that support human intelligence and action, but reflect limited intelligence in their own right. Once inputs or expectations of the function go outside the narrow machine specification, it's good as a goal to drive research and development forward. However, our definition could be misleading when it comes to practical AI that can be applied today. A good working definition of artificial intelligence is a machine that perceives its environment and takes action to maximize the chances of successfully achieving its goal, such as an autonomous vehicle or car, strategy games like chess, robots for assembly, robots for surgery, medical diagnosis, processing vast amounts of symptoms and data to come up with a conclusion and a recommendation, simulation or electronic trading. So why is AI important? It improves what's possible, makes safer, faster, cheaper, or better. How does it differ from traditional computing? Well, it learns and creates new information and knowledge from large sets of data inputs and memory. It can change itself in a sense, in that it can change the rules and algorithms to improve processing and its decision making. In effect, it's a self-improving environment, improving its own performance. If designed correctly, it can improve all dimensions, but most importantly, it improves its own value and quality. Neural networks are machines that mimic how the brain works in structure and in function. Learning, recognition, analysis, and the sophistication of dynamic problem solving are carried out. An algorithm is a type of formula used to solve a specific problem. It's used in traditional and intelligent computing devices. Deep learning indicates a machine that uses structured self-learning based on human learning models. Data mining is part of data science and analytics, which considers exploring large and complex data sets to identify meaningful relationships and meaningful patterns in the data. Natural language processing, or NLP, well, that relates to the human to voice to computer communications. Chatbots are commonly used now in online customer support and services. They simulate human interaction from the service provider. Cognitive computing is, in effect, a computerized model that mimics the way the brain thinks and involves self-learning through data mining, natural language processing, and pattern recognition. Applications of artificial intelligence. Personal assistants, whether standalone or on a device such as Cortana, Siri, or Alexa, are good examples where AI techniques are used to continually provide improved personalized service to the user based on what they learn about them. They continually enhance speaker voice recognition. Autonomous vehicles, such as cars, are close to fully replicating being driven by a human, leveraging technology to simulate all the senses, continually learning about their environment and making appropriate decisions relating to their movement. Fraud detection. Financial fraud of all types can be detected and sometimes prevented by using data science techniques and AI to identify potential fraudulent patterns of activity. Predictive purchasing is now commonplace in both business and consumer marketing, on and offline. Potential buyers are presented with offers they are more likely to convert to purchases based on their profile and history, and also the analysis of other purchases and behaviors that relate to users with similar interests. We have discussed chatbots earlier. Often the consumer of customer services does not realize they are talking to a machine rather than to a human service agent. Trading robots are in common use for several years now, using sophisticated algorithms, neural networks, and predictive analytic techniques to make decisions, to buy, to sell, or to hold financial instruments being traded, often at very high speeds. Thanks for your attention. I hope you found this video useful and informative. Below you can see other videos in the digital series. If you need any further information, you can go to the listed websites, or you can email me at info@intelligentorg.com. Thank you again.